Hello there, welcome to this tutorial. It's on application of differentiation, and in this video we'll be looking at tangents and normals to curves, where we'll be calculating the equation of tangent and normal as well as their gradients. Now let's consider the graph below. This is a quadratic graph, or we call it the graph of polynomial of degree 2. So if we pick any points along the curve, call it this point P. If we draw a straight line through that point and name it AB, the line AB is called the tangent to the curve at P. So that's the tangent to the curve at P. And also if we draw another line, call it PQ, which is perpendicular to line AB. So the line PQ is called the normal to the curve at point P. So what we'll be doing in this video is to find the equations of this tangent and this normal. So we go to the first problem. Problem 1. Find the gradient of the curve y equal to 2 minus 3x minus 2x squared at the point T, x comma y, where x is equal to negative 3. Hence, find the equation of the tangent to the curve at the point T. We know the derivative of any function is the gradient function. That is the first derivative of any function is the gradient function. Therefore, we are going to find the gradient function of this curve. Then from there, we substitute x is equal to negative 3 to get the gradient of the curve at that particular point. So we find the y, the x. The derivative of a constant is 0, so that one is gone. The derivative of negative 3x is negative 3, and the derivative of negative 2x squared is negative 4x. So you can check some of our videos on differentiation. Now, to get the gradient, we let m be the gradient of the curve at x is equal to negative 3. So that will be dy dx at x equal to negative 3. Then we now substitute x is negative 3 in this function. So we have it as negative 3 minus 4 into negative 3. Negative 4 times negative 3 gives positive 12 plus negative 3 gives 9. So at this point, x comma y, we need to find the y, the value of y at that point. To find the value of y at that point, we substitute x is equal to negative 3 in this function. So that we now have y equal to 2 minus 3 into negative 3 minus 2 into negative 3 squared, and that will give us 2 plus 9. This is 9 times negative 2 gives negative 18. So simplifying this, we have y equal to negative 7. Now we know the gradient of the equation we are looking for. That is the equation of the tangent now. So the equation of the tangent at the point negative 3 and negative 7. X is negative 3 and y is negative 7. So having known the gradients, we get the relation m equal to y minus y1 over x minus x1. This is one of the many relations. If you are given a point and the gradient to find the linear equation, this is one form. We'll be looking at the other form in the subsequent problems. So we substitute our m equal to 9. This is 9 equal to y minus negative 7. Since this is y1, this is x1. This is over x minus negative 3. Cross multiplying, this is going to change to positive 7. So we have y plus 7 equal to 9x plus 27. This is positive 3 times 9, which gives positive 27. Now take this to the side, y equal to 9x plus 20. Since this will go to the other side to become 27 minus 7, which gives 20. So that is the equation of the tangent to the curve at the point T. And we have done justice to that problem. We go to problem 2. For problem 2, find the equations of the tangent and normal to the curve y equal to x squared plus 6x plus 9 at the point negative 2, 1. We are given 1 point and we need the gradient to enable us find the equations of the tangent and the normal. So we are going to find the first derivative, which is the gradient function of this curve, and put in the value of x, which is negative 2, into the gradient function to give us the gradient of the curve at the point negative 2, 1. So we go, that is our m will now be the y, the x at x equal to negative 2. And what we do is differentiate this x squared, which gives 2x plus 6. Substituting x is negative 2 in this gradient function. So our gradient will be 2 into negative 2 plus 6. This is negative 4 plus 6, which gives 2. We can then go ahead to find the equation of the tangent. Now, we are going to use the other relation. That's y equal to mx plus c. And we know our m is 2. So y equal to 2x plus c. Since we don't know the value of c at this point, we can now go ahead to find c by substituting the values of x and y at that point. So when y is 1, so we have y is equal to 2 into negative 2 plus c. This is negative 4. Going to this side, it becomes plus 1. So c is equal to 5. We can now go ahead to substitute c in this relation to give us the equation of tangent to the curve at the given point. So we have y equal to 2x plus 5. And that is equation of tangent. Now we look at equation of normal. Now, since normal is perpendicular to tangent, to get the gradient of this normal, it is negative reciprocal of the gradient of the tangent. And since the gradient of the tangent is 2, the negative reciprocal will be negative half is equal to y minus 1. We are using the previous relation over x plus 2. This is negative 2 minus minus becomes positive. So cross multiplying, we have a 2y minus 2 is equal to negative x minus 2. So rearranging this, we can bring this to this side. It becomes x plus 2y is equal to 0. This negative 2 coming here becomes positive. Negative 2 plus 2 gives 0. And that is the equation of the normal to the curve y equal to x squared plus 6x plus 9 at the point negative 2, 1. So we are done with problem 2. We go to problem 3. For problem 3, find the equation of the tangent to the curve y equal to x cubed plus 2x squared minus 3x plus 1 at x equal to negative 2. So what we do here again, we find the gradients and then also find the value of y at the point x is negative 2. So our gradient will be the first derivative of this function at x is equal to negative 2. So we have the y dx at x equal to negative 2. That will give us 3x squared plus 4x minus 3. Now substituting x is equal to negative 2 here, we have 3 into negative 2 squared plus 4 into negative 2 minus 3. This is 4 times 3, which gives 12, minus 8 gives 4, minus 3 gives 1. So the gradient of the tangent is 1. Since the gradient of the curve at that point is 1, so the gradient of the tangent is 1. Now, having gotten the gradients, we are going to find the value of y at the point x is negative 2 by substituting x is negative 2 in this function. So we have y equal to negative 2 cubed plus 2 into negative 2 squared minus 3 into negative 2 plus 1. And simplifying this, we have y equal to 7. So our tangent now will be, we'll start with y equal to mx plus c. And since our m is 1, so it means y is equal to x plus c. To get c, we put in the values of x and y. This is x is negative 2, y is 7. So we have 7 equal to negative 2 plus c. Bringing this to this side, c is equal to 9. Now, having gotten c, we substitute into this relation so that the equation of the tangent will be y equal to x plus 9. And that is the end of solution to problem 3, and this is the end of this tutorial. I hope you enjoyed it. Please subscribe to our YouTube channel, like and share this video. Also check the description section of this video on our YouTube channel for more videos on applications of differentiation. Until we come your way again, goodbye.